everyone, my name is Belle, and I'm currently a doctoral researcher in learning, education, and technologies. With a background in learning science and apply AI in education, I'm passionate about how AI transforms the way we learn, interact, and also in making AI more accessible to learners. Welcome everyone to our sessions on Introduction to Artificial Intelligence. So in these first few slides, we'll outline the journey that we will explore today. What AI is, why is it emerged, and where it is headed. Think of this as the settings, the stage for our entire discussions. We are aiming to understand AI not just as a futuristic concept, but as a technology that is very real in daily life, from smartphone apps to online services. Well, one may ask, why pay attention to AI? The simplest answer is that it helps us see how machines learn to mimic our decisions-making process. This does not mean that machines are smarter, rather they are trained to recognize patterns. Our talk today will address how this happens, the historical event that led us here, and some common myths about AI. Let us begin by looking at what we'll cover. These modules will focus on what is AI, how does AI come to be, common misconception about AI, why it is important to learn about AI, and our interactions will be interactive in spirit. Each part will build on the last, so by the end, everyone will see the big pictures. We'll focus on tangible examples such as navigation apps, online shopping, recommendation, and digital tools for the classroom. AI is not an abstract idea, it's a set of methods that help computers learn from data. That is our starting point. What is AI? Now, I'm going to start with these warm-up questions. When you hear the word AI, what is the first thing that pops into your mind? Take a moment to think about this. Does that image fall into any of these categories? The westward idea of robot taking over our world, some other end on the scale of sci-fi movies, or general some smart app like Siri, Google, ChatGPT, or you are not too sure altogether. With that confusions, let's get ourselves grounded on this basic definition of AI. AI, or artificial intelligence, is about teaching machine to learn from data and make decisions, much like how humans learn from experience. How is this different from most computer program or the tool that you ask? Well, regular computer program typically follow a fixed set of commands. So if a user is inputting data into a traditional program, that software will respond in the same manners every single time, the way that it has been designed and instructed. AI, in contrast, it evolves with every new piece of information it encounters. Imagine it as a student that gets better with practice. In this module, we'll break down the core concepts that make AI both fascinating and transformative. Let me illustrate the mechanism of rule-based program further. Picture a person coaching a computer to spot an apple. They'll hand it 10 distinct apple photos, explaining all of these apples. The computer would nod and fire them away. Next, the person revisits one of those images and asks, is it an apple? The computer would proudly say, yes, because it remembers that specific photos. Then here comes the twist. A fresh apple picture appears. What is this? The coach asks. The machine draws a blank and answers, no, unable to connect it to the saved image. So without any real learning, it cannot handle anything beyond those original 10 pictures. Now, let's switch gear to an AI-based system. The same person shows 10 apples, photos, labels apples. Instead of just storing identical snapshots, the AI starts to recognize the key features such as shape, color, textures. And when being asked, is this new picture an apple? The AI would compare those features to its learned patterns. Even if the photo is at a new angle or at a slightly different color, the AI would understand and say, yes, this too is an apple. That's the real difference. AI learn from examples and form a flexible patterns rather than simply remembering precise images. So in this learning sense, we can say that AI has all capabilities in seeing, hearing, and thinking. But seeing would referring to computer vision mechanisms like when your phone cameras identifies face friend. Or hearing can be speech recognitions, for example, Amazon Alexa or Apple Siri. It can interpret your voice command. Thinking pointing to making predictions based on data, like when an e-commerce site suggests the products. Each of these abilities emerge from the model training on a large amount of data. However, that does not mean that AI understands in a human sense. It learns from example and then apply that in learning. So in this sense, we should better perceive that AI is not magic, it's not omnipotent, but they can learn from example. The more example that you give, the better they become. How does AI came to be? Believe it or not, AI is not new. Our journey began in 1956 at the Dartmouth Conference, where the term artificial intelligence was coined. But since then, we have witnessed incredible milestones from AI defeating a chess champion in 1997 to breakthroughs in computer vision in 2012, and leading to AI ability to learn and detect objects in photos. And then you have creative AI generating art and music in 2018. Of course, around 2020 is the unmissable appearance of ChatGPTs, or more in a bit term of like generative AI, has the ability to understand and generate new content from text-based to multimedia content like images, audios, videos. And then we can fast forward to today in 2024, with the focus is actually on creating AI that is ethical, safe, and transparent. So this timeline shows us that AI isn't just a sudden intervention. Decades of research coupled with leap in processing powers, data availability has moved AI from science fiction towards to everyday tool. Now, many people might wonder if AI equal robot taking over the world. Well, AI is more actually about teaching machine to learn from data and make decisions. For instance, an image classification models simply identify which photo contain cat. This is about finding pattern, not planning world dominations. Now, let's break down the core process of AI. So at its heart, AI take in data, analyze it, and find pattern, and then make predictions. While AI might contain algorithm and automation aspects, one might not mean the others, so it is important to distinguish and understand these separately. First, think of algorithm as the blueprints, a set of steps to solve a problem, much like a cooking recipe, a series of set of steps to cook a meal. Automations use that blueprint repeatedly. So if you can imagine like a machine factories running at the same instructions over and over again. But AI go further. It does not just follow instructions. It also study as is automate. It keep learning from the large amount of data to make new decisions or predictions. It constantly updates its approach based on its learn. So in short, AI builds on the notion of structured step from algorithm. It automates step, but it differs in adaptability. So before we detail the inner working of AI, so this will introduce two aspects that are very much involved with this process. The first one is analytical thinking. What is it? So this type of reasonings involve breaking problem down into smaller parts. in an educational settings, one might break down a complex research question into simpler segments, a small hypothesis, for example, like investigating user behaviors, and then exploring the technologies that addresses those behaviors. So AI development follow these patterns by deconstructing tasks into data gathering, pattern recognition, and then prediction. Moving on, we have structural thinking. Now, this is about putting those smaller pieces in the proper orders. So using a recipe as an example, if you line up all the ingredients that you have, now you need to follow certain steps in a logical sequence. In AI, the system must handle the input, processes, produce an outcome, and then learn from the feedback. If these steps are out of orders, the system fails. So imagine trying to train a chatbot even collecting the relevant text data. The structures have ensured each stage connect effectively to the next. So together, these two skills help us design and troubleshoot AI system effectively. When you're building or refining an AI-based learning app, it's important to first break down its function, and then second, arrange them so that they use the data collections, model trainings, and result feedback form a sensible loops. If we skip any step, the system might produce incorrect or incomplete response. That is why AI projects require both detailed analysis as well as step-by-step organizations. So, in short, AI daily operation would contain these four main steps. First, data collection. Second, learning from those data. Then, making predictions. And lastly, improving over time. So let's put these ideas into a bit more practical context. So consider scenarios where we want an AI to identify fruit. First, we collect thousands of images of apples, bananas, and orange. Next, the AI will look for patterns. So apple might be round and red. Banana might be long and yellows, and orange, well, they have their own distinct features. The AI then uses this pattern to predict the identifiers of new images. And if it makes a mistake, we corrected it, and then the system will learn from that error. This is how AI gets better over time. Now, let's talk about the two important subsets of AI, machine learnings and deep learnings. First, what I meant by subset, in simpler terms, we can say that all machine learning and deep learning application is AI, but not all AI is machine learning and not all AI is deep learning. So at a higher level, machine learning involve algorithms that learn patterns from data, which on the other hand, deep learning is a subset of machine learning that is neural network, structures inspired by the human brain to learn complex patterns automatically. Now, while machine learning can work with smaller data set and is often requires some human input in selecting the features, deep learning thrives on huge data set and it can discover intricate patterns on its own. Each has its own strength and ideas use case, whether it is predicting house price or powering self-driving car. So in that sense, we can see example like predicting house price or even recognizing a handwritten digit. This might be handled well by machine learning, but to distinguish complex objects in image and speech-to-text, self-driving car, this actually call for deep learning. Now, as educators, you have a very critical role to play. AI is transforming teaching and learning processes, automating gradings, personalized learning experience, and even providing insight to student process. For educators, understanding AI means enhancing classroom efficiency and preparing students for futures where technology is deeply integrated into every aspect of life. By integrating AI into your curriculum, you are not only teaching a subject, you are empowering future innovators. So, there are three main things of why, as educator, you should learn about AI. First, enhancing teaching method. Educators who understand that AI can transform traditional teaching method by incorporating intelligent tools that personalize learnings and automate routine tasks. Imagine using AI to create adaptive lesson plan that can cater to each student pace and learning style. This will not only make your teaching more dynamic, but it also free up valuable time so you can focus on engaging with students more deeply. With AI, you can seamlessly integrate multimedia resources, interactive simulation, and even real-time feedback into your curriculum, making complex subjects more accessible and exciting. Helping students navigate the futures. In today's rapid evolving digital landscape, preparing students for the future is more crucial than ever. Educators with AI literacies are better equipped to guide students through emerging technologies and critical thinking challenge. By understanding AI, you can teach students how to interact with, question, and then harness this technology responsibly. This means that not only giving them the skill to thrive in a tech-driven economy, but also empowering them to be innovators and ethical decision makers in a world where AI increasingly shapes every aspect of our life. Lastly, enhancing classroom efficacies. AI can boost classroom efficacy by streamlining administrative tasks and optimizing learning environment. Tools powered by AI can help automate grading, track student progress, and even identify learning gaps before they become major challenges. This allows you to monitor each student journey more effectively and then adjust your teaching strategies in real time. As a result, the overall efficacies of the classroom improve, creating a more supportive and responsive educational setting that benefits both student and teacher alike. Now, let's put all these ideas together into a case studies. Think about your day, from the moment you wake up to when you go to bed. Can you identify at least 3 moments where AI might be helping you? Well, maybe it is in the recommendation engines on your favorite streaming service, or the navigation system that guide you in your commute, or even the way your smartphone personalize notification. This exercise just to help us see that AI isn't just a buzzword, it's a part of your daily life. So let's summarize what we have covered today. We began by defining AI and exploring how it's different from traditional rule-based program. We look at the evolution of AIs from its early days to today focus on ethical and responsible AI. We also discuss how AI learn from data through a process of pattern recognition and continuous improvement. And we compare machine learnings with deep learning. Finally, we look at common misconceptions and explore why learning AI is crucial. Now, as we wrap up, remember this. AI doesn't shape the future on its own. We do. Your understanding of AI can help guide its development, ensuring that it's used responsibly for the greater good. Stay curious, keep learning, and always approach new technology with both enthusiasm and critical mind. Thank you for joining me for this exploration of AI, and I look forward to our continued journeys into the world of AI.